Hi, this is experiment 1 and its name is viscosity. We're gonna need for our experiment water, cooking oil, marbles, and 2 glasses. So the first thing we have to do is we have to pour water into one of the glasses and then pour oil into the other. Now the next thing we're gonna do is that we're gonna take our marbles and then we're gonna drop 3 of the marbles into the water. So it's gonna be from here. Then we're gonna drop 1. We're gonna drop the second one, and at the end the third one. Now, we're gonna repeat the same steps using the cooking oil. We're gonna drop the first marble from here, the second one, and the third one. So that's the end of our experiment. So now I'm going to read you the questions that we have to answer for our experiment. It says to note and compare the speed with the falling marbles in both cases, the water and the oil. And then when you do that, you have to interpret which one was faster. And I believe the marbles that we used with the water were faster. Why do you believe there's a difference of speed, if any? I believe there's a difference of speed because it was really obvious that the marbles from the water fell faster, and it was actually because there is less friction and viscosity in the water, so this allows the marbles to move and fall faster than in the cooking oil. So it was mainly the friction and the viscosity that made a difference between speed. Thank you.
What's surface tension? What's the meaning of this? Today we're going to do a little experiment about this topic. To begin, let's see a brief explanation of what surface tension is. It's the elastic tendency of liquids which makes them acquire the least surface area possible. First, we're going to need a glass of 200 millimeters like this one, an old razor, the flat ones, and a pen. The first step is to drop the razor to the glass of water, like in the video that I'm showing you, in a vertical way. Then you draw the pen horizontally. See the differences? There's none, they both sink. But if you drop the razor horizontally, it floats. This is due thanks to the force applied by the razor when you put it vertically. It breaks the surface tension of the water and sinks. While the pen sinks, thanks to the force too applied by the pen and the shape of the pen. And finally, there's the razor that floats in the water. The razor, if you put it in this way, horizontally, the force is distributed among the whole thing. And that's why the razor floats.
Hi, my name is Irving, and I'm going to present you the Pascal principle. Here I have 2 eggs, 2 glass, water, and salt. The first step is to add water in these 2 recipies. It has to be in 3/4 of each capacity. Then I have to add 12 tablespoons of salt to 1 glass. Then you have to mix it very well. So the final step is to put each egg in each glass. So let's see what happens. This one goes to the bottom of the glass, but this keeps floating, as you see here. This happened because the density in this glass is bigger than the egg one, so that's why it goes to the deepest place. The buoyancy force in this case is smaller than the density of the water. That's why it falls down. But in this case, the air keeps floating. That's what the buoyancy force is bigger than the density.
Okay, I am doing experiment number 4, which is about Pascal's principles. For this experiment, I am going to use 2 syringes, one of 3 millimeters and one of 20. As you can see, they are not filled up to the top, as it is instructed in the instruction. And we also use this plastic tube to connect both syringes together to pass the liquid from one side to the other. And we also need to use half a kilogram object, but since we can't place it good right here, we're going to not use it. Okay? But what we need to see here is how the liquid passes to the other syringe with only using little force, which is what Pascal's principle is about. The area of this is larger than this one, but with the liquid, it will move it very easy, as we're going to see right now. See? Move all the way up. Okay? It's pretty easy, huh? Even though one's larger than the other. So this is what Pascal's principle states. And the area of the small sky ring is 0.001884 meter squared. That's the area of this one. And the area of the big one is 0.005074 meters cubic meters. These are the 2 areas. Okay, and that's the experiment number 4.